Hello, ladies and gentlemen, and welcome back to more of our Grade 7 Gauss paper. We're on question 20 now. Betty and Anne are walking around a rectangular park with dimensions 600 meters by 400 meters as shown. They both begin at the top left corner of the park and walk at constant but different speeds. So Betty seems to walk this way and down this way. Betty walks clockwise and Anne walks counterclockwise. I should really comment after I've read the whole question, but I never learn. Points P, Q, R, and S, and T divide the bottom edge of the park into 6 segments of equal length. Okay. When Betty and Anne meet for the first time, they are between Q and R, somewhere in there. Which of the following could be the ratio of Betty's speed to Anne's speed? Okay, 5 to 3, and so on. So we need sort of a rough estimate for Betty's speed and a rough estimate for Anne's speed. And we will likely get that in the form of a fraction. Okay. So let's draw our picture here. Well, a picture. We might draw some more pictures. Who knows? So it was P. We will go all the way up to T, and these divide the bottom of the park into 6 equal segments. So P, Q, R, S, and T. And so we've got, if it's 600 by 400, then it'll be 100 meters each. P, Q, R, S, T. Okay. So, what does Anne do? Anne comes down by 400, and then she goes across at least by 200, possibly by a bit more. So, Anne's sort of distance, let's say, is between 700 meters and 600 meters. She definitely goes past Q, but doesn't go past R before the meeting takes place. Betty goes 600, then 400, and then back by 100, 200, at least 300, but no more than 400. So, Betty's distance. So 1,000 to get to the corner, 100, 200, 300. So at least 1,300, at most 1,400. Okay. So I understand we've got some sort of bounds on their distance. Now we want to talk about their speeds. And we specifically want a ratio of their speeds. Well, I'm going to call Anne's distance that she traveled, it's clearly the smaller one, so we'll call that D. We'll call Betty's distance capital D. And I might also talk about their speeds, so that S, well, S and capital S sort of look similar. So how about we use A for Anne's speed, B for Betty's speed. Okay. Now, we want to talk about the ratio of their speeds, and we want Betty's speed to Anne's speed. So that's sort of like figuring out this fraction B over A. Well, what do we know? I know that the distance Betty travels is her speed times this time to, let's call it T equals time to first meeting. And Anne's distance, well, distance is also speed times time, and it's the same time in each case. So what we can do is we can rearrange these and say, well, D over T is Anne's speed, and capital D over B is Betty's. Capital D over T is Betty's speed. Wrong equation. There we go. So then I can replace these D over T and little d over t, and the little t's cancel each other out, so we get big D over little d, and we have some possibilities. Okay, now we know that 600 less than d less than 700. So if we were looking at d over d and we wanted this to be big, we know that this is going to be less than big D over the smallest possible little d. Because if you divide by a smaller number, you get more in each part. And so we also get capital D over 700 is going to be less. But we also know that capital D is at most 1400 and is at least 1300. And so now we can say, well, D over 700 is at least 1300 over 700. And D over 600 is at least 1400 over 600. Alright, but these are simpler fractions if we start dividing, so we can say 13 over 7 and 7 over 3. Alright, so this tells us sort of a range of values for the fraction of Betty's speed, or the ratio of Betty's speed to Anne's speed. So we're presented in the question a number of possibilities. 5 to 3, 9 to 4, 11 to 6, 12 to 5, 17 to 7. So all of these are our possible fractions. 5 over 3. The last one was 17 over 7. I do not remember the ones in between. 9, 4, 11, 6, 12, 5. 9, 4, 11, 6, 12, 5. But only one of these should satisfy our inequality here. Okay. Only one of these should do. Okay. What can we say here? Well, I suppose we could just grab our calculator real quick. 5 over 4. Well, actually, let's figure out the range. 13 over 7 is just a little less than 2. We'll say it's about 1.85. And 14 over 6, that's more than 2. That's about 2.33. All right. Now, 17 over 7 catches my eye. It's way more than 2.33. Okay. Now, 12 over 5, that's a little more than 2, but is it too much? Yeah, it is. 2.4. How about 11 over 6? That's not going to be more than 2. It's going to be a little too less. 1.83, unfortunately. Okay, 9 over 4, that's going to be a little bit more than 2. It's 2.25. It's sitting well in that range. 5 over 3, 1.66. So the only one that's in this range is going to be 9 over 4. All right. Was there a faster way to see that? Not really. I suppose you could give this all a common denominator, but since there's a 4, 5, 6, and 7, that's going to be a really, really big common denominator. Not impossible. I'm just saying it's a bit beyond you, but if you, like, bit beyond worthy of your time, not beyond your capabilities. I'm sure everyone out there knows how to multiply, but it's just so much easier if you grab a calculator. So 9 to 4, or 9/4, is our ratio for B to A. All right, and if I've aligned these up properly, that's going to be an answer of B. Yes, B indeed. And that finishes off part B, so we're going to be starting part C in the next video. The last 5 questions, these should be the harder questions. So if you haven't, take a look at them, try them out, and yeah, in the meantime, have yourself a wonderful day, and I will see you for more of the Grade 7 Gauss later.